Hi, I'm Raina Fitzgerald, and in this lesson we're going to look at the slope-intercept and point-slope forms of a line. Okay, let's start with slope-intercept form of a line. And we'll begin by drawing an x-axis, and I'm drawing it down here below, and I'm going to move it up, so let's move this up. And now let's draw a y-axis, and I'm going to draw a y-axis over to the right. This is freehand, so they're not perfectly straight. Okay, and let's take our y-axis and put it right here. And now let's draw a line. We'll draw a line in blue. Here's our line. And our line should have an arrow at both ends showing that it goes on forever. Now the location where the line touches our y-axis is our y-intercept. And we're gonna call our y-intercept B. B is a constant. It represents where the line intersects the y-axis. Okay, now let's take a look at the slope. The slope, which is m, represents the rise over the run. So let's write a slope right here, m. That's our slope. M tells us that given any 2 points, a starting point and an ending point, we want to know what was our rise and what is our run. So I'm going to change the color, and we want to know how high must we go up and how far to the right do we go to start at one point and end up at another point on the line. And that gives us our slope, which is m. So let's go back and let's go to what we're looking at here is slope-intercept form. So here's slope, and slope is represented with an m. And intercept is our y-intercept, and we use a b to represent the y-intercept. Well, the form for this equation is y is equal to m, which is our slope, times x plus b, which is our y-intercept. Keep in mind that both the x and the y represent variables. So the x, here's the x, let's bring the y down here. Here's the y, and each ordered pair, x, y, can be plugged into this equation and have it be a true statement. Now, let's do an example here. Let's put some values in here. So let's imagine that b is equal to -1. And let's say that the slope, if we calculated out the slope, that the slope happened to be 2, up 2 over 1. Then the equation for this blue line would be y is equal to a slope of 2 times x plus a y-intercept of -1. Here's an example. We're given the point 0, 5 and a slope of 2/3, and we want to graph it and write an equation for this line. Now if the slope is 0, if the point is 0, 5, that means x is 0, y is 5. There's the point right there. So that point represents our b. That represents the y-intercept because it's where it touches the y-axis. So right away from this point, I know that b, which is the y-intercept, is 5 because when x is 0, y is 5. I also have my slope over here, that the slope is up 2 over 3. So right away I can write the equation for this line as y is equal to a slope of 2/3 times x plus b, which is 5. Of course, I'm using the slope-intercept form. Y equals the slope m times x plus the intercept, the y-intercept b. So there's our equation for the line right here. Now let's graph it. Starting at the y-intercept of 5, I want to use the slope, 2/3, which is up 2 over 3. So I'm going to do that in red. So we're going to go up 1, 2, and now we're going to go over 3. 1, 2, 3. And this puts us at our next point. 2 points to determine a unique line. We'll do one more point though, that's fine. We're going to go up 1, 2, over 1, 2, 3. There's another line. So these 3 points are collinear. Let's connect these points, and this is again freehand, so try to keep them on the line as much as possible. So here's our line, and this is a graph of the line that has a y-intercept of 5 and a slope of 2/3, up 2 over 3. Here's another example. In this example, we're not given the slope. Instead, we're given 2 points. The first point, 0, 2, is when x is 0, y is 2. And that point, in fact, is the y-intercept. So we know right away that our y-intercept, which is b, is 2. Now we need to find our slope. Well, the formula for slope is the change in our x value over the change in the y value. So I can start with taking the points here to the right and taking the y from the right-hand point minus the y from the left, and the x from the right minus the x from the left. You have to be careful to go in the same order for each one. So in the numerator, I'm going to start with the y from the right, which is 3, minus the y from the left point, which is 2. In the denominator, I'm going to start with the x from the right point minus the x from the left point, which is 0. Well, this is subtraction, and we want to change it to add the opposite. And of course, 0 and negative 0 are 0. So 3 plus a negative 2 is 1. And 3 plus 0 is 3. So our slope is 1/3. Okay, so now we have the slope. So let's start at our y-intercept and move up 1 and then over 1, 2, 3. And here is our next point. And all we need to do is connect these points to graph our line. Now, how do we write the equation for this line? Well, we have b, which is our y-intercept. We also have 1/3, which is our slope. So we can write the equation for this line in slope-intercept form. Y is equal to mx plus b, where m is 1/3 and b is 2. Now let's look at point-slope form. Point-slope form means that you're given a point, and let's call the point x1, y1. The reason I'm writing these with subscripts of 1 is because I'm not talking about all x and y values. I'm only talking about a specific ordered pair, and that is x sub 1, y sub 1. So for point-slope form, we need to have at least one point, and then we also need to know m, which is the slope. So these are the two things that would be given in point-slope form, is a point and a slope. So the formula for point-slope form is that y, representing all y values, minus the y sub 1 from our point, is equal to the slope times x, representing all x values, minus the x from our slope. And this is the equation that represents point-slope form. So our given is we have a point and a slope, and this is our linear equation. Let's try an example. Imagine we're told that we have a line that goes through the point 2, -3. And we were further told that the slope is 1/4. And we needed to write the equation for the line. So let me move this over. The equation for the line would be y minus the y value, which is a -3, is equal to a slope of 1/4 times x minus the x value. Now, if we wanted to graph this, we can simply find this point and then rise up 1, run over 4, find another point, and connect those 2 points. Let's try another. Let's say we're given the point 3, 12, and the slope that we're given is 2/3. And we're asked to write the equation for the line that goes through this point and has this slope. We would say y minus our y value from the point is 12 is equal to our slope, which is 2/3, times x minus our x value, which is 3. So here I've moved these down so it's a little easier to see. And so when we're using point-slope form, again, we just need a point and a slope. This is the formula, and we just plug in the xy point, x1, y1, and the slope to get our equation. In our 2 examples, our blue example, our point is 2, -3, and our slope is 1/4, and we merely plug in 2, -3, and 1/4 to get our equation. Here in our red equation, our point is 3 and 12, x is 3, y is 12, our slope is 2/3, and all we have to do to get the equation is start with our original equation and plug in the 3 and the 12 for our point and 2/3 for our slope. Here we have another example. We're given 2 points and we're asked to graph the points and to write the equation for the line. The first point, -3, -4, let's graph that. X is -3, and that puts us right here. And y is -4. 1, 2, 3, 4. That puts us down here. So let me make my line a little thinner and draw our guidelines coming down from -3 and over from -4. And we get our point, which I'll do in blue. That's our first point. That's the point -3, -4. Now let's graph the point 1, -2. So I want to go with black. So x is 1 and y is -2, which is right here. So that would put us, and I think what I'm going to have to do is see if I can get rid of that -2. I think I'm going to put the -2 on the other side right here. I think it's going to get in the way of the line. I may anyways get in the way. So here's the point. X is 1, y is -2. And I'll put the guidelines in here coming down from 1 and over from -2. There's our point. Now let's connect those 2 points. And I'm going to make my line thick again. So if we connect these 2 points, we have our line. 2 points determine a unique line. But how do we write the equation? Well, we have 2 points. And if we look, we have point 1 and point 2, for example, our 2 points. Here they are. And we know so far that there are 2 forms. Well, we've actually learned 3 forms for writing the equation for the line. We can write it in standard form, which is ax plus by equals c, and that's not going to help us here. We have point-slope form, which is y minus y1 is equal to the slope times x minus x1, that's our point-slope form, and then we also have slope-intercept form, which is y is equal to the slope times x plus the intercept of b. So these are 3 forms for a line, and we can write the equation for this line using any one of these 3 forms. Actually, I want to get rid of this, and what I want is the pointer, right? So this equation right here, we can write it using any one of these 3 forms. But the first form, well, this one I'm not really prepared to write because I don't know a, b, and c. The second form, I need a point, x1, y1, which I have 2 of them, but I need a slope, and I don't have a slope right here. In the third form, I need a slope and an intercept, and I have neither of those. So I think what I'm going to do, the best way to do this is to use the second form. I have 2 points and not a slope. However, I can find the slope. Let's do that. I can find the slope. I know that the slope is equal to the difference of my y values and the difference of my x values. So I'm going to take these values on the right and subtract from the values on the right. So starting with the difference of my y values, I'm going to have, and I'll stick with blue, a -2 minus a -4. That's the difference of my y values going from my right point to my left. And the difference of the x values will be 1 minus a -3. Now I need to work this out, but before I do, let's change the subtraction to add the opposite. And then in the numerator, I have a -2 plus 4, and that's going to give me a +2. And then in the denominator, I have a 1 plus 3, and that's going to give me a 4. So 2 divided by 4 is 1/2, so I have my slope. So now I can write the equation for the line, and I'm going to use this form right here. I'm going to say y minus my y value. Now it doesn't really matter which y value you use, the one on the left or the one on the right. I'm going to take the y value from the right. This is the point I want to use. Let's use this one. I'll put a box around it so I know this is the point I've decided to use for my equation, and this is the slope, of course. Okay, there we go. Put a box around that. Okay, so finishing off our equation, we have y minus our y value from our point, which is a -2, is equal to a slope of 1/2 times x minus the x value from the point we selected, which is a 1. And let's box this because this is our final answer. This is the equation for our line. And oftentimes we want to say add the opposite. So I would make that to add a +2. So really it's y plus 2 is 1/2 times the binomial x minus 1.